All right, we're going to continue our talk about radicals expressions. The objective for today is I will learn to add and subtract radical expressions. So your heading is adding and subtracting radicals. All right, the one thing that you need to know about adding and subtracting is that you can only add like terms. Or subtract. So in this case, I can add the 3 square roots of 5 and the minus 2 square roots of 5. It's like having an expression where we have 4x plus 3y plus 2x. You can only combine the stuff that has the same variable in it. So on here, you can only add the things that have the same radical, simplified radical. So since 5 and 7 are prime, there's nothing for me to simplify other than to go ahead and combine them. So it's a positive 3 minus 2. That's going to leave me 1 square root of 5 plus 2 square roots of 7. Okay, I don't really need that 1 there, so really it's just square root of 5 plus 2 square roots of 7. That's your answer. That's simplest form. Because you can't simplify the square root of 5, you can't simplify 2 square roots of 7. Alright, so I'm going to try this one with you. I'm going to go ahead and see what I can simplify. I can factor this into 2 times 5, but that's not going to reduce. Same thing with that one. Now 225, this I can reduce. That's actually going to be, so 3 square roots of 10 minus 6 square roots of 10 plus 2, and the square root of 225 is 15. So I rearranged it, and then I went ahead and simplified this 2 square roots of 25, which comes out to 2 times 15, since square root of 225 is a perfect square. Okay, 3 minus 6, that's going to give me a negative 3 square root of 10 plus 30. Okay, kind of another thing with standard notation, we typically put the constant minus 3 square roots of 10. Okay. And I'm going to leave you with that one. This will be your example that I want you to work. And I will be looking for this one on your notes to check and see what you came up with as an answer. Alright, now we're going to kind of do a little bit of algebra review to kind of refresh your memory on exponents. So this exponent here tells me that I have 3 of these. It's 3a to the third power times 3a to the third power times 3a to the third power. So I'm going to multiply the 3's together. 3 times 3 is 9, times 3 makes 27. And now the part you probably might have forgotten is these exponents right here. Okay, so kind of, if I have a to the third, that means I got a times a times a, right? So I have 3 of those. So really what I have is I have a times a times a times a whole bunch of a's. And really what that means is that I have 9 a's. So this should actually be 27a to the 9th power. Okay, so you add the exponents. If it's the same base, you can add those together. All right. Example I'll be checking on your notes is number 5. All right. Again, some word problems doing the same thing. Jasmine wants the area of a square in square units of a rectangle that has a width of 3x and a length of 4x squared y squared minus 4. So remember that area is length times width. So I'm going to do 4x squared y to the 4th power times 3xy. Same thing, we add, actually, I'm sorry, we combine like terms, we multiply the constants, that's 12. I add the exponents. If there's nothing written, there's understood to be a 1 there, so there's going to be x to the 3rd power and y to the 5th power. Okay, and let's go ahead and put, this would be square units. All right, and the last example that I want you to try, Blake says the sides of a square are 9x squared y cubed. What is the area in square units of the square? That's just going to be area of the square is equal to s squared, or side squared. All right, I'll leave you that one to solve on your own.